Good afternoon. For those who are joining us for the first time, please note that we are currently running free classes, so which means that since registration is ending end of March, we are going to have another additional free class that we're going to be conducting as well. And the login details to that class, which is going to be held via Zoom, and also the timetable is going to be shared with the different groups as well. So please keep that in mind. Also, for those students who want to benefit from being able to prepare for the coming classes as well, and to view the videos of the class that we've done this year as well, please note that we are currently giving free access via the trial version that we create for you so that you're able to access the material. We are able on the trial package that we have available until the first week of April. We are going to be giving free access to for you to be able to download the soft copies of the textbooks, which is already highlighted with a bit of notes on it, and you're also able to view the videos of the classes that we did last year, so that you can use these classes to prepare for the coming classes that we're going to be having as well. And then the videos of the classes that we did so far are also going to be uploaded so that you're able to access them on the user account as well. So which means that for those students who are joining us now, please note that there's still one more free class that we're going to be conducting. The details will be shared on the different WhatsApp groups. Also, if you want to be able to access the material that we have and also to access the videos of the classes conducted as well, we are going to be sharing the details to our website, where when you create the user account on our website, you need to indicate to us so that we know which modules you want to be linked as well. Creating the user account on its own, nothing shows. But on our side, we need to now authorize so that we know which modules you want to be linked, then we'll link those modules, then you're able to view those modules as well. So that's basically how we are going to be giving access when it comes to the students who are joining us when it comes to the trial package as well. Are there any questions before we proceed with the study units? Any questions? All right. So if you check in the study guide, you'll see that in the study guide, we were still looking at learning unit 1. So we're looking at learning unit 1. And remember, learning unit 1, it's part of topic 1. And remember, for topic 1, we need to go through learning unit 1, and then we need to go through learning unit 2. Now, for learning unit 1, which is our agenda for today, is to do the rest of learning unit 1. In the previous class, we did unit 1.1 to unit 1.3. So in today's class, to unit 1.2. So in today's class, we're going to do unit 1.3 until the rest of the chapter 1, so that we make sure that whatever we did in chapter 1, we're on point as well. When it comes to learning unit 1 in the exam is a highly examinable section of the text of the exam. It's a highly examinable section of the exam. So please make sure that you take note of everything that we have covered in learning unit 1. And also, if there's anything that you don't understand, I'm always available to address any questions that you might have when it comes to things that we have covered in the textbook as well. So please note that today, our agenda is to finish chapter 1 of learning unit 1, because there's still quite a bit of information that we need to go through there. And you see that because it's a very important learning unit, we cannot just brush through it. We need to make sure that you guys understand exactly what needs to be covered as well. So you see that the next part of the chapter that we need to cover, we were now looking at the capital asset pricing model. So we were now looking at the capital asset pricing model. And when it comes to the capital asset pricing model, they say a common procedure to use historical data and regression analysis to determine a best fit linear relationship between returns from an investment and returns from the market portfolio. So this relationship has the form of this way, where R, which is the return from the investment, is equal to A, which is a constant, plus B, which is also a constant, multiplied by RM, which is your return on the market portfolio, plus E, which is basically a random variable. And this, which is a random variable equal to the regression error as well. And this is how we determine the return. So your return is your alpha plus beta multiplied by the return on the market portfolio plus a random variable. So this is the basis from where the capital asset price model was where the capital asset price model comes from. So here they say equation 1.3 shows that there are two uncertain components to the risk in the investment return. Component number one is where they say a component beta multiplied by RM, which is the multiple of the return from the market portfolio. And then the second component is the component E, which is basically unrelated to the return from the market portfolio, which, remember, this is what we said is the error term when it comes to the regression error as well. So here they say the first component is referred to as systematic risk, and the second component is referred to as non-systematic risk. So the first component of this formula, which is this part of the formula, this is where you find your systematic risk. And then the second component, which is the error term, is where you find the non-systematic risk. So here they say, now consider first the non-systematic risk, which is your error term. If we use that the A variable for different investment are independent of each other, the non-systematic risk is almost completely diversified away in a large portfolio. So before we go there and look at it in detail, let's try to see exactly and understand what is this systematic risk and unsystematic risk that they are referring to. Now, we know that the total risk faced by an investment is given as systematic risk plus unsystematic risk. So the total risk faced by an investment is given as your systematic risk plus your unsystematic risk. Your systematic risk is also referred to as non-diversifiable risk. This risk is also referred to as uncontrollable risk. Then the unsystematic risk is also referred to as the diversifiable risk. And this diversifiable risk is also referred to as controllable risk. So the risk that affects everyone within an economic system is what we refer to as systematic risk or diversified risk. Now, because it's a risk that affects everyone within an economic system, we have no control over whether we can increase or decrease our risk exposure to this, because what? It's affecting everyone in the economic system. Hence, we refer to it as uncontrollable risk. The unsystematic risk is that risk which is specific to the investment. So the risk that specifically affects the investment of your choice there is what we refer to as the unsystematic risk or diversifiable risk. So this risk can now be reduced by having different investments in your portfolio. So the more different investments you have within your particular portfolio, the more this risk what goes down. Hence, we refer to it as what? Diversifiable risk. Now, because we are able to reduce the risk depending on exactly how many different assets we have in our portfolio as well, we say we refer this risk as what? Controllable. Now, your total risk that you face, it's measured using the standard deviation. So how you measure the total risk? The total risk is measured using the standard deviation. Remember in the previous class, we saw how to calculate the standard deviation of a single asset, and we also saw how to calculate the standard deviation of what? Of a portfolio of two assets as well. That's the standard deviation. And it's represented by this sign. Now, the risk that is systematic risk. So systematic risk is measured using beta. And as a sign, this is how you represent the beta. So your systematic risk there is measured using the beta. And this is how you look at the beta. Are we on the same page so far? Any questions? Now, so this unsystematic risk is basically the one that we're referring to as the regression error. So this unsystematic risk is basically what we're referring to as the regression error. Are we on the same page? Any questions? Anyone lost? So please take note of these different terminologies that are used to describe these different types of risks as well. So in the textbook, they go on to discuss this, and they say the first component where you look at the beta multiplied by the market return is referred to as your systematic risk. And the second component is referred to as the non-systematic risk. Consider first the non-systematic risk. If we assume that the error variable for different investments are independent of each other, the non-systematic risk is almost completely diversified away in a large portfolio. An investor should not therefore be concerned about non-systematic risk and should not require an extra return above the risk-free rate for being non-systematic risk. The systematic risk component is what should matter to a well-diversified investor. So which means when they're talking about the non-systematic risk being relevant there, they're saying when you now look at this relationship of these risks there and you put them on a graph, so you look at the relationship of these risks and you put them on a graph there, they are saying if we plot the total risk against the number of different securities. So if you plot the total risk against the number of different securities, we see that now the risk which does not change because that's the risk that we have no control over. So the risk that does not change, because that's the risk that we have no control over, we refer to this risk as your systematic risk. Now, this risk that reduces depending on exactly how many number of different securities we have in our portfolio. This is what we refer to as your unsystematic risk. So which means ideally in a portfolio, we are saying as the number of different securities goes down, we are expecting that the unsystematic risk should go down until it reaches a level where we no longer have unsystematic risk, and the only risk we are going to be facing is systematic risk. So ideally, in a portfolio, we are saying the only risk that we must end up only worrying about is systematic risk, because if the portfolio is well diversified by having many different securities there, the risk is going to go down to such an extent where your unsystematic risk is no longer no longer there. The only risk that's going to be remaining is the systematic risk. Are we on the same page? Any questions? Anyone lost? Now, on the next section, they say, we know how investors trade off systematic risk and expected return from figure 1.4. When beta is 0, there is no systematic risk, and the expected return is equal to the risk-free rate. Now, when you now look at the figure that they are referring to, figure 1.4, they are referring to figure 1.4. So on figure 1.4, they are saying this is the point where we have the risk-free rate, isn't it? Now, from the point where we have the risk-free rate, we are saying if the systematic risk if the unsystematic risk is no longer there, it means that we are going to be earning the risk-free rate. So if the systematic risk is 0, it means the investor is going to be earning the risk-free rate. Now, where this comes from, they are already explaining a principle that is important, that is covered in the capital asset pricing model. So here, to park that thought for now, and let's read this again further. When the beta is equals to 1, we have the same systematic risk as the market portfolio, which is represented by point M, and the expected return should be equal to the expected return on the market portfolio. Now, this is how they're explaining the capital asset pricing model. Now, how they are arriving at this explanation for the capital asset pricing model? Where the capital asset pricing model comes from? We said in general, when it comes to how the banks determine how much interest they charge you, we say your nominal interest is given as your real interest plus inflation premium plus risk premium. So effectively, we are saying your nominal interest is given as your real rate plus your inflation premium plus your risk premium. And this is how we arrive at the nominal interest rate. Remember I said this is the mother of all formulas that are where any formula that is based on interest rate calculation comes from this mother of all these formulas. Because if you look at this formula, we also know that the real rate plus inflation premium gives you the risk-free rate. So it gives us the risk-free rate. So your nominal interest rate can also be given as the risk-free rate plus the risk premium. So your nominal interest rate can also be given as the risk-free rate plus risk premium. Now, when you now look at the formula that they're giving us there for the capital asset pricing model, so if you now look at the formula that they're giving us for the capital asset pricing model, they're saying your expected return based on the capital pricing model, your expected return is given as the risk-free rate plus your beta in brackets, your market return minus your risk-free rate. So your expected return, if you look at the formula that they give us for the capital pricing model, your expected return is equal to the risk-free rate plus beta in brackets, market return minus risk-free rate. Are we on the same page when it comes to this formula? Please note that the difference between the market return and the risk-free rate of return, they refer to it as the market risk premium. So they refer to it as the market risk premium. Now, let's go back to the first statement that they mentioned there so that we can see where is this statement coming from. They say, we know how investors trade off systematic risk and expected return from figure 1.4. When beta is 0, there is no systematic risk. Remember we said systematic risk is measured by beta, isn't it? So when the beta is 0, it means that there's no systematic risk and the expected return is the risk-free rate. Now, let's look at this formula here. If your beta here is given as 0, if your beta is equal to 0, right? What does that mean? Any number, remember the beta is multiplying what's this bracket, isn't it? So 0 multiplied by any number is 0, isn't it? So when the beta is equal to 0 here, what does that mean? The expected return is equal to the risk-free rate. Do you see where the argument is coming from? So when the beta is equal to 0 here, any number multiplied by 0 is 0. So it means when the beta is 0, where we are saying that there's no systematic risk, automatically it also means that the expected return of the asset is equal to the risk-free rate. That's where the statement is coming. Also, they say when beta is equal to 1, we have the same systematic risk as the market portfolio, which is represented by point M. I'm not going to go back to that. And the expected return should be the expected return in the market. Now, when beta is equal to 1, when beta is equal to 1, Now, remember here, we looked at the instance where the beta was equal to 0. Now, when your beta is equals to 1, so when your beta is equal to 1, when your beta is equal to 1, what you need to take note of is, please take note, the beta that we're talking about here, the beta we are referring to here is, with the beta that we're referring to here, so when we talk about the beta there, the beta that we're referring to here is the beta of the asset. So this beta that we're referring to here is the beta of the investment. So this is the beta of the investment. Please take note, as a golden rule, as a golden rule, so as a golden rule, the beta of the market is always equal to 1. So as a golden rule, the beta of the market is always equal to 1. We'll look at that in more detail when we look at the calculations as well. So as a golden rule, the beta of the market is equal to 1. So what does that mean? When your asset has a beta of 1, automatically it means the market beta is also equal to 1, as we have said here. So it automatically means the asset has the same systematic risk as the. So the moment you see that the asset is being referred to as having a beta of 1, it means, remember we said beta measures systematic risk, isn't it? So it also means that when the asset is a beta of 1, it means it has the same systematic risk as the market. So when an asset has a beta of 1, it means it has the same systematic risk as the market. Now, mathematically, I'm going to demonstrate this, but I'm going to erase it because I'm just going to demonstrate what they're trying to say. Remember here on the statement, they say when beta is 1, we have the same systematic risk as the market portfolio, which is represented by M, and the expected return should be the expected return of the market. So what this means is, if the beta is equals to 1, it means your expected return is equal to the risk-free rate of return plus 1 multiplied by the market return minus the risk-free rate of return. Because we're saying the beta is equal to 1, right? If we expand this equation, it means your expected return is equal to the risk rate of return. Now, if you expand this bracket, it's going to be 1 multiplied by Rm, which gives us Rm, and 1 multiplied by minus Rf, it gives us minus Rf. Are we on the same page so far when we've expanded the bracket? So what does that mean? It means a positive Rf is going to be cancelled out by a negative Rf. So that's why they say when an asset has a beta of 1, automatically it means the expected return should also be equal to the return in the market portfolio. Are we on the same page? Any questions? Anyone lost? So based on this is how they are giving us that breakdown for this is how they are giving us that breakdown for the calculation of the expected return. When they say, so the expected return, just give me a second. The expected return based on the capital asset pricing model is given as the risk rate of return plus beta in brackets market return minus risk of return, and say this is the capital asset pricing model. So this is the basic breakdown of the capital asset pricing model. Yes, is there a question?
Yes, someone on the comments is asking you to repeat the last part.
Remember we said the beta is equals to 1, right? So in our formula here, we're going to replace beta with 1. Now, since we have replaced beta with 1, we're going to expand this bracket. And 1 multiplied by Rm is Rm. 1 multiplied by minus Rf is minus Rf. So your expected return here is going to be equal to a positive Rf and a negative Rf. They cancel out each other, isn't it? So it means your expected return is equal to the same as the market return. So if the beta is equals to 1, automatically it means your expected return of the asset will be the same as the return in the market. Any other questions? Moving on. So diagrammatically, the relationship between the different returns can be given in figure 1.5. So diagrammatically, the relationship between the returns can be given in figure 1.5. So when you look at the relationship between the returns, here, they are saying, in figure 1.5, they are saying, when you plot the expected return against the beta, we are saying this relationship can be shown by a graph, which is something like this. And here we're saying, remember by definition, the risk-free rate is the return that you're getting without exposing yourself to any risk at all. That's your risk-free rate, isn't it? So your risk-free rate plots at this point of the graph, because you're saying you are earning this return when your beta is equal to 0. Remember, beta measures risk. So you're earning this return without exposing yourself to any risk. And then what did we also see? When the beta of the asset is equals to 1, the beta of the market is equals to 1, it also means the expected return should be equal to the market return. So which means diagrammatically as well, when you are plotting the betas now, we are saying when the beta of the market, when the beta is equals to 1, when the beta is equals to 1, so when the beta of the asset is equals to 1, what does that mean? You are expecting the expected return to be the same as the market return, isn't it? So when your beta is equals to 1, automatically you expect to earn the return in the market. But it's an expected return because it's not an actual return.
I'm sorry, Rhinos. Can you please repeat that?
Remember here we saw that when your beta is equals to 1, right? Your expected return of the asset is going to be the same as the market return, isn't it? Right? So when your beta is equals to 1, so when the beta of the asset is equals to 1, your asset is going to be earning the same return as the market return. Are we on the same page? When your beta is equals to 1, it's demonstrated here. We saw that the expected return of the asset is the same as the market return. So when your beta is equals to 1, we are saying the expected return of the asset is going to be the same as the market return. And remember, the beta of the market is always equal to 1. Are we on the same page?
Yes, thank you.
Are there any other questions before we proceed? Now, moving on, they say they give us this example. But before we look at this example, I also need to demonstrate how do we calculate this beta. So I also need to demonstrate how do we calculate this particular beta as well. So I need to demonstrate exactly where does this beta come from. So how do we calculate this beta? Remember we said in this case, when you look at the beta, we are saying your beta measures systematic risk. So your beta measures systematic risk. So how do we determine this systematic risk? Or how are we going to be able to calculate this beta? Now, mathematically, if you still remember mathematically, we said the gradient of the curve is given as change in y over change in x. So the gradient of the curve is given as change in y over change in x. Are we on the same page? Now, if the gradient of the curve is equal to change in y over change in x, it means we are saying on our graph, if you check out our graph here, this is where we find the y-axis, and this is where we find the x-axis. Now, remember we said beta measures risk. So we said beta measures risk, right? Now, if beta measures risk, we are saying if you have two assets, where if you have one asset and the return in the asset is given on the y-axis as the expected return of the asset, if the return in the asset is given on the y-axis and the return in the market portfolio, remember we said when your beta is equals to 1, when your beta is equals to 1, it means the beta of the market is always going to be equal to 1, isn't it? So which means if we are going to be plotting on the y-axis, we look at the turn of the asset, and on the x-axis, we look at the movement of the different beta of the different assets, or the movement of the beta as well. What it means is that when we look at this particular graph as well, we are saying, when we look at this particular graph, we are saying that if the gradient of the curve is measured by beta, so if the gradient of the curve is measured by beta, it means the beta, if the gradient of the curve is measured by beta, your beta can be given as your change in y over change in x. So your beta can be given as your change in y over the change in x. So your gradient of the curve can be given as your change in y over your change in x. So which means, in this case, your y-axis would represent the change in the asset returns, and your x-axis would represent the change in the market returns. So in that case, it would mean if gradient measures the curve, if beta measures the gradient of the curve, if beta measures the gradient of the curve, it means your beta can also be given as a change in y over change in x. So your beta can also be given as your change in y over your change in x. Now, if that is the case, it means your beta can also be given as your change in asset returns over your change in market returns. So your beta can also be given as your change in asset returns over your change in market returns. So your beta can also be given as your change in asset returns over your change in market returns. And your asset return is just R of the iron top. So which means the reason why we are saying the beta of the curve is always going to be, the beta of the market is always going to be equal to 1. The reason why we are saying this is mainly because any number, what if you are given to say, let's say for example, the beta is equal to 5. Let's say for example, they give you that the beta is equal to 5, right? It means automatically it's 5 over 1. And if it's 5 over 1, automatically you are saying the beta of the asset is the one that is, the beta of the asset is the one that is 5, and the beta of the market is the one that is equal to 1. Now, mathematically, the beta can also be given as, the beta can also be given as the covariance of the asset in the market divided by the standard deviation of the market squared. So the covariance of the asset, so the beta can be given as the covariance of the asset in the market divided by the standard deviation of the market squared. And this is another way that you can also look at the beta. Now, We are going to look at this later on as well, when we analyze covariance later in more detail as well. And the covariance can also be given as the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset multiplied by the standard deviation of the market. So when we look at covariance later on in detail, we are going to explain this relationship as well. So the covariance of the asset in the market can be given as the correlation coefficient of the asset in the market multiplied by the standard deviation of the assets multiplied by the standard deviation of the market. Now, the standard deviation of the market squared is the same as saying the standard deviation of the market multiplied by the standard deviation of the market. So the standard deviation of the market squared means the standard deviation of the market multiplied by the standard deviation of the market gives you the standard deviation of the market squared. Which means when you simplify this equation, the numerator here is going to be cancelled by the denominator there. Which also means that the beta can also be given as the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset divided by the standard deviation of the market. And this is how you can also arrive at the beta. The reason why I'm giving you all this information is mainly because in some instances, it's not all the time that they're going to give you the beta. So it's not all the time that they're going to give you the beta. If they give you the correlation coefficient of the asset in the market, and they give you the standard deviation of the asset, and they give you the standard deviation of the market, you should be able to find the beta as well. Also, if they tell you the asset returns changed by so much, and then they tell you the market returns changed by so much as well, it means the change in the asset returns divided by the change in the market return should also enable you to calculate the beta. So please make sure that you look at these different examples of or different ways that you should be able to deduce your beta in your calculations. So just to do a quick recap, in the exam, they normally give you the beta. But there are some instances where the lecturer might try to make it too complicated for you to deduce the beta. So if they tell you that the asset returns, for example, increased by so much, and then the market returns increased by so much, or maybe they'll give you the return in the asset, and then they'll give you the return in the market. It means the return in the asset divided by the return in the market would tell you what the beta is equal to. At the same time, if they give you the correlation coefficient between the asset and the market, and they give you the standard deviation of the asset, and then they give you the standard deviation of the market as well, you should also be able to determine the beta of the asset. Remember, by default, the beta of the market is always going to be equal to 1. Are we on the same page? Any questions? So, going to the example that they are giving us there. So, looking at the example that they're giving us there, they give us example 1.1. Please note, what I was discussing just now is what is being given here. Before we look at example 1.1, they say the parameter beta is equals to the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset divided by the standard deviation of the market, where this is the correlation coefficient between the return in the investment and the return in the market, And this is the standard deviation of the return in the investment, and this is the standard deviation of the return in the market portfolio. So beta measures the sensitivity of the return on the investment to the return in the market portfolio. So in simple terms, they are saying another way that you can also present beta or calculate beta or determine beta is where you can plot the return of the asset against the return in the market. So the return of the asset on the y-axis against the return in the market, you can now be able to look at the gradient of this relationship between these two. And this is how you determine the beta. So which means the return in the asset becomes your return change in I with an I. And your return in the market becomes your change in R, which means that this is your y-axis and this is your x-axis. So which means beta basically measures the gradient of the curve. Remember, the gradient can be anything. It can move in this direction, can move in that direction, or can be whatever. So you can calculate the beta by saying your change in asset return on the y-axis divided by the change in market return on the x-axis. That's how you can determine beta. You can also determine beta by saying the beta can be given as the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset divided by the standard deviation of the market. And this is how you determine the beta as well. What I did here, I just showed you where this calculation is coming from, because in the textbook, they are just giving you this final amount, but there is somewhere where this final amount is coming from, which also means the beta can also be given as the covariance of the asset and the market divided by the standard deviation of the market to the power of 2. So please take note of these different ways that you can be able to determine the beta, because to try to make your question a bit difficult in the exam, the lecturers are not always going to give you the value of beta. So in calculating the expected return here, they might not give you the value of beta, but what do they give you instead? They give you change in asset return against the change in market return. Or they can give you the covariance of asset I and M, and they give you the standard deviation of the market. Or they can give you the correlation coefficient of I and M, and then they give you the standard deviation of the asset, and then they give you the standard deviation of the market as well. So these are the different ways that they can try to confuse you in the calculation of the expected return, because they can actually call the expected return, but not give you the beta, and you need to calculate. So can we look at example 1? All right. Now, looking at example 1, they give us that information. So here they say, suppose that the risk-free rate is 5% and the return on the market portfolio is 10%. An investment with a beta of 0 should have how much as the expected return. So if the beta is equal to 0, how much is going to be the expected return, right? So what do we see? For the first part of the question is where we are saying that the beta is equal to 0. So remember the expected return is equal to risk-free rate of return plus, so it's your risk-free rate of return plus, in bracket, plus beta, so it's your risk rate of return plus beta in brackets, market return minus risk-free rate of return. And this is how we would arrive at the expected return. So in the case where beta is equal to 0, we're going to say your expected return should be equal to, in the question, they tell us that the risk rate of return is equal to 5%. So we're going to say 5 plus the beta, which is 0, and the market return is given as 10%, minus the risk rate of return, which is equals to 5. So given this information, how much do we get as the expected return?
5.
So your expected return is going to be equal to 5%. Going back to what was demonstrated before as well, right? Where we said when the beta is equals to 0, it means the expected return is the same as the risk rate of return. Then they also go on to say, this is because all of the risk in the investment can be diversified away. So if the risk is diversified away, it means when your beta is equal to 0, because remember beta measures systematic beta measures systematic risk. It means that when your beta is equal to 0, the only return that you're going to be able to earn is going to be the risk-free rate. Now, an investment with a beta of 0.5 should have an expected return of how much? So in the case where the beta is equal to 0.5, so in the case where your beta is equal to 0.5, now the question becomes, how much would be your expected return? So in that case, your expected return, holding that everything else remains the same, is going to be the risk rate of return of 5 plus the beta of 0.5 in brackets, the market return remaining the same at 10 minus the risk rate of return, which is equals to 5. So given this information, how much would be the
7.5.
7.5. So the expected return would be equal to 7.5%. Are we on the same page? Now they also give us another scenario where they say an investment with a beta of 1.2 would have an expected return of how much? So an investment with a beta of 1.2, which means when the beta is equals to 1.2, the expected return is equal to the risk rate of return of 5 plus the beta of 1.2, market return of 10 minus the risk rate of return, and how much should we get as the expected return?
Should be 11.
11.
It will be equal to 11, right? Now, remember we said your beta measures the gradient of the curve, isn't it? And your beta is your change in the asset return divided by the change in the market return. So your beta is your change in the asset return divided by the change in the market 10. So your beta is your change in the asset return divided by the change in the market. So what do we see? When your beta is equals to 0, this is the same as saying 0 over 1, isn't it? Right? When your beta is equals to 0.5, this is the same as saying 0.5 over 1. And when your beta is the 1.2, this is the same as saying 1.2 over 1. Are we on the same page? So what does that mean? What this means is a beta of 0, this is the asset beta. And the 1 here is the market beta. Remember we said the beta of the market is always equal to 1, isn't it? So what does that mean? When a beta is equal to 0, remember we said beta measures systematic risk, isn't it? When a beta is equal to 0, it also means the asset has less systematic risk than the market. Are we on the same page there? When a beta is equal to 0, it means the asset has less systematic risk than the market. Are we on the same page? And if your beta is 0.5, we're saying this is the asset beta, and this is the market beta. So what does that mean? 0.5, if you convert it to 1, it means when an asset has a beta of 0.5, it means the asset has less systematic risk than the market. It's got less systematic risk than the market. And when the beta is 1.2, this is your asset beta, and this is your market beta. So when the beta is equals to 1.2, it also means the asset has more systematic risk than the market. So when the beta is 1.2, it means the asset has more systematic risk than the market. So they can typically ask you to interpret these values of beta as well in the exam. So in the exam, they typically would ask you the interpretation of this beta to say, so what does that mean? Does it mean the asset has more systematic risk, the same systematic risk, or less systematic risk than what? And you should be able to interpret it. Are we on the same page?
Hi, Ranos. Can you kindly just repeat that again, starting from where the asset beta is 0 over 1, whereby the market is 1, and cascading down to whereby the asset beta is 1.22.
Do you understand where we're getting this 1 in the denominator? Where it's coming from?
Not really. Hence, I wanted to understand where does it come from?
When
Is
your
it already
beta, when your beta is 1, is 0, right? Whatever amount they give you as a beta there, you are just going to put it divided. You're going to say simply divided by 1. Whatever amount they give you as the beta of the asset there, remember we said your beta measures systematic risk. Your beta is equal to your change in asset return over change in market return, isn't it? Right?
Yes, yes.
So which means, let's say for example, as an example, they say your asset return increased by 18%. So your asset return increased by 18%. And at the same time, your market return increased by 10%. Right? So your asset return increased by 18%. And at the same time, your market return increased by 10%. So if you're calculating the beta there, it's going to be 18 divided by 10. How much do you get?
1.8.
18 divided by 10. So your
1.8.
answer is going to be 1.8. Your answer is going to be 1.8, isn't it? Right? Now we are saying, if your answer is 1.8, this is the same as saying 1.8 over 1, isn't it? So if you simplify it there, your value of 1.8 is going to be 1. Is the same as saying 1.8 over 1, because any number divided by 1 is that number, isn't it? So your value of 1.8 is the same as saying 1.8 over 1. So what does that mean? Remember, we said beta measures risk, isn't it? So which means looking at these values, when you look at these values, it also means that the beta of the asset, which is the one on top, is this, and the beta of the market, which is the one at the bottom, is that. Right? Now, so after simplifying this, if they just say your beta is equal to 0, automatically it means it's 0 over 1. Because how we compare and calculate the beta, we say change in asset return over change in market return. So the change in market return is always going to be the denominator of the change in asset return. So if the beta is given as 1.8, it's the same as saying 1.8 over 1. And because of this, mathematically, that's why we said the beta of the market is always going to be equal to 1. This is where it's coming from. Because whatever beta you calculate for your asset is always going to be divided by 1, which is the beta of the market. So if that is the case, if you have an amount for beta of the asset being so much, automatically it means this amount is being divided by 1, which means this is the beta of the asset and this is the beta of the market. Are we on the same page? So whatever amount you get as the value of beta there is always going to be divided by 1 all the time to reflect the beta of the market. Now, to see whether this asset has more systematic risk or less systematic risk than the market, this is where you're now going to compare the value of the numerator against the value of the denominator. If the value of the numerator is more, it means the asset has more systematic risk. And if the value of the numerator is less, it means the asset is what? Is less systematic risk. So here, 0 is less than 1. Hence, we say the asset is less systematic risk. And here, 0.5 is less than 1. So the asset is less systematic risk. But here, 1.2 is greater than 1. So here, we say the asset has more systematic risk. Are we on the same page?
Yes, I'm covered. Thank you.
Are there
Sorry.
more questions?
Yes. Yes. I want to find out, let's say the asset beta and the market beta, like you said, for the first one, the asset beta is less than the market beta, ne? And then let's say second option is the asset beta is equal to the market beta. And then the third one, it's exactly like that one. The third one where the asset beta is bigger than or larger than the market beta. So we've got three, let's say we have three different options. And then from an investor's, I don't know, side, which option would be the best option to go with? Will it be when the beta is equal to, when the asset beta is equal to the market beta, or where the asset beta is smaller or bigger than the market beta?
The decision is dependent on the investor's risk appetite. So the decision is dependent on the investor's risk appetite. Remember in the previous class, if you still remember in the previous class, we said when we looked at this section, there's this section that we looked at in the previous class. When we looked at the efficient frontier, there's a graph that I prepared there, which shows the return against, okay, it's not showing here. There's a graph that I prepared there which shows the different investments which shows different investments. If you still remember in the previous class, where we said if you have two investments, A and B, and then the question becomes, which investment would you choose between A and B? And we said you choose what? Investment A, because they are all exposed to the same amount of risk, right? And then we also said, if you have investment C and you're asked to choose between investment B and C, which of the two investments would you choose? And we said you would choose investment C because for the same return, C is exposing us to less risk, isn't it? And then I also said your choice between investment C and investment A is dependent on how much is your risk appetite. Given that everything else remains the same, you are going to expose yourself to more risk if you have a higher risk appetite so that you earn more returns. So the same applies here. Your choice of the beta on its own is not important. What is important is the risk-return relationship. So this risk that you're exposing yourself, how is it compared to the return that you're expecting to earn? If you expose yourself to so much risk, how much is that compared to the return that you're expecting to earn as well? Does it mean that if you expose yourself to more risk, you're going to end up earning more return? So that's how you would answer your question on exactly so which beta is better. It all depends on what is your risk return relationship and what is your risk appetite. Are we together? All right. Any questions? Any question to clarify? Are you answered? Do you need further clarification? Any questions?
Follow-up question. So let's say the return is exactly the same for all the three examples, but the betas are different, like you said. Which one then would be the best one? Would it be the one with the lowest beta?
It's like this one, where we say, for example, if the return is, if you're choosing comparing investment C and investment B, right? And maybe investment C, they tell us that your beta is 0.5, and investment B, they tell us that your beta is equal to 1.2. And then you're asked, which investment would you choose? Investment C or investment B? Which one are you going to choose then?
C.
Investment C, because for a lower beta, which is your risk exposure, you're still earning same return.
Oh, okay.
So it all goes back to this relationship that we looked at in the last class as well.
Okay, no, thank you so much.
Right. So your choice of the investment is very much dependent on the risk-return relationship, not just by looking at the betas. You need to look at the risk-return relationship. Are we on the same page? Any questions? Anyone lost? All right, can we take a 10 minutes break until 3:35? So can we take a 10 minutes break until 3:35? Then at 3:35, we look at assumptions. So can we take a 10 minutes break until 3:35? Then at 3:35, we look at assumptions. All right, can we continue? Looking at section 1.3.1, we look at the assumptions with regards to the capital asset pricing model. And here they say, under assumptions, the reason why the analysis leads to conclusion that do not correspond with the realities of markets is that in presenting the arguments, we simplicitely made a number of assumptions. In particular, remember we are referring to the capital asset pricing model, right? The assumptions were, first one, we assumed that the investor care only about the expected return and the standard deviation of the return of the portfolio. So that was the first assumption. And then the second assumption is we assumed that the variable E are the error variables for different investments in equation 1.3 are independent. Then the third assumption is we assume that investors focus on returns over just one period, and the length of this period is the same for all investors. And we assumed that investors can borrow and lend at the same risk-free rate. So this is approximately true in normal market conditions for a large financial institution that has a good credit rating. But it is not true for small investors. And the fifth one is we did not consider tax. And then finally, and perhaps most importantly, we assumed that all investors make the same estimates of expected returns, standard deviation of returns, and correlations between returns for available investments. So to put this another way, we assumed that investors have homogeneous expectations. In simple terms, the assumption there is that we are assuming that investors have the same expectations, which is not always going to be the case. So please take note of these assumptions regarding investors. Now, on the next section, we also look at the alpha. And before we look at the alpha, they give us example 1.2. So can we quickly read through example 1.2 and we go through it together? So before we look at the alpha, can we look at example 1.2 and then we go through it together? So for example 1.2, they say, consider a portfolio with a beta of 0.6 when the risk-free interest rate is 4%. When the return on the market is 20%, the expected return of the portfolio is how much? We want to find out exactly, so what is the expected return of the portfolio? If the beta is 0.6, the risk-free rate is 4%, but in the case where the beta, or in the case where the return of the market is equal to 20%, we need to find out exactly what would be the expected return. So in this example, we are saying, example 1.2, now in example 1.2, they say if the beta is 0.6 and the risk-free rate is equal to 4%, now given these figures, what will happen? So what will happen to the expected return in the case where the market return is equal to 20%? So if the market return is equal to 20%, what will be the expected return? And remember, we say your expected return is given as your risk rate of return, which is 4%, your beta of 0.6, your market return of 20 minus the risk rate of return, which is equals to 4. So given this information, how much do you get as the expected return of the portfolio? How much would you get as the expected return of the asset?
$13.6.
So the expected return of the asset would be equal to 13.6%. We're on the same page. Any questions? Anyone lost? Now they give us another scenario. They give us another scenario, and they say when the return in the market is 10%, the expected return from the portfolio is how much? So in this case, initially the market return was 20%. Now they are saying if the market return is 10%, what will happen to the return of the expected return? So in this case, we are saying if the market return is equal to 10%, the expected return in that case would be equal to risk rate of return of 4 plus the beta of 0.6, market return, which is now 10, minus risk rate of return of 4. And in this case, how much would you get as the expected return?
%7.6%.
So the expected return will be equal to 7.6%. Any questions? Anyone lost? They give us another scenario. And here they say, when the return from the market is minus 10%, the expected return from the portfolio is how much? So when the return in the market is minus 10%, what would be the expected return? So in this case, when the market return is equals to minus 10%, now we are asking what will be the expected return. And your expected return is given as the risk rate of return of 4 plus the beta of 0.6, market return of minus 10 minus risk rate of return of minus risk rate of return of 4. How much would you get as your expected return?
Minus what? Minus 4.4%.
Yeah. It will be minus 4.4%. It will be minus 4.4. So this is what they're trying to demonstrate when you look at these calculations here. So overall, they are saying the relationship between the expected return on the market portfolio and the return on the market, so the relationship between the expected return of the portfolio and the return on the market is shown on figure 1.6. So this relationship here is being shown on figure 1.6, something like this, where they are saying, when you look at this relationship as well, when you look at this relationship, we are saying that when the return on the market is 10%, when the return on the market is 10%, we are expecting that the expected return of the portfolio should be somewhere here. And remember, this is where we find 7.6%. And if the return of the market is at 20%, we are expecting that the market the expected return of the portfolio should be this amount. And if the return on the market is minus 10%, we also expect the asset return to be sitting at this amount of there as well. So which means when the return on the market is minus 10%, we expect the asset return to be somewhere there, which is where we find minus 4.4%. So this graph now, which plots like this, is the one that is showing that relationship as well. Are we on the same page? Now, remember, yeah. Yes. Yeah, I didn't get the question. Remember, the graph is just showing us the relationship between. So remember here, we saw that.
I have a question. And then the example that we're dealing with, you've converted yours. Sorry,
Sorry? I didn't get the question.
Okay, I was saying that I see that you use the 4 instead of the 0.4, 0.04. I wanted to see if maybe we're working it differently.
Oh, no, it's the same. Please note, any calculation of a concept covered in chapter 1, to make your life easier, use these values as full values, not as decimals. And then where there's need, if you use the full values like what I did there, not as decimals, make sure that you round off to 4 decimal places if there's a need to round off 4 decimal places. Are we together? All right.
Will they indicate that we must round it off?
Okay.
That it must be in
I'm
decimal.
saying it's because historically, what we have noticed is that some of the questions that the lecturer brings in, if you do these calculations in decimals and then the final answer, putting it back to percentages there, ideally the lecturer says, if it's a complicated calculation, if you're rounding off these values and it's a complicated calculation where there's a lot of decimal places that you need to take into account, if you put it in decimals, put it to 8 decimal places. Then if you put the amount in what? In full values like what we did here, put them what? In 4 decimal places to get the exact answer that the system wants you. Because remember, some of your assignments, the system is going, your answers on the some of your assignments, the answers are going to be based on the input that you're going to be, you are just going to put the input, the answer, and not necessarily show the calculation. And because of this, the system is going to be very sensitive on the number of decimal places for your final answer as well. So if you don't do the right, if you don't get the right rounding off like what the system is wanting you to, you are going to end up being marked incorrectly. That's why I said, when it comes to any question that is coming from concept covered in chapter 1 of the textbook, rather deal with them as full values than putting them as decimals. Because if you put them as decimals, you need to convert to decimals and then convert back to full values when you're now putting the final answer. So rather, leave them as full values. And if you leave them as full values, where there's need, round it off to 4 decimal places. Are we together? All right. Is there another question?
I don't know if it's a question, but your volume is a bit faint on my end. I don't know if it's my side or your side. I don't know if I'm the only one.
I'm not sure, but please just try to ensure that where you are seated, you have a good network connection. Because if you don't have a good network connection, sometimes the volume becomes a bit wobbly. So you need to check, because if you check on your at the bottom of your screen there, it also sometimes shows you exactly how good your network connection is. Ideally, it should be showing you white. If it's showing you anything less than white, it means your network connection is a bit wobbly. All right, is there another question? All right, now, I think someone did ask me to demonstrate how we plot these values. Remember we said when you're plotting these values, we saw that when the market return was 20%, we saw that our expected return on the portfolio was an amount of which was equal to 13.6. So 13.6% you find it somewhere here. And when your market return was 10%, we saw that your expected return of the portfolio was equal to 7.6%, and 7.6% you find it somewhere here. And when your market return was minus 10%, we see that the expected return on the portfolio was minus 4.4%, and minus 4.4%, you find it there. So which means this is how they now plot this graph to show this relationship between market return and expected return of the portfolio. Are we together there? All right. All right, moving on. Now, remember they also ask us to look at the alpha. And when you look at the alpha, this is your excess returns. So your alpha is basically your excess returns. So here they say, the portfolio manager has produced, so which means when you now look at your return of the portfolio against the expected return, right? So when you look at the return of the portfolio against your expected return, we're now comparing to say, how did the portfolio actually do compared to the expected return? So the comparison between the return of the portfolio to the expected return is what we refer to as your alpha, or the extra return. Now, in this case, we are saying your alpha is equal to the return of the portfolio minus your expected return. And this is how you determine your alpha. So in this case, your alpha is this. So this is your alpha. And this alpha is also referred to as your excess return. So this alpha is also referred to as your excess return. So this alpha is also referred to as your excess return. So your alpha is where you're comparing the actual return of the portfolio against the expected return based on the capital asset pricing model. Now, when we look at this, remember we said your expected return based on the capital asset pricing model is shown by this, isn't it? Which means your alpha is also return of the portfolio minus the expected return, which is given by risk rate of return, beta, market return, minus risk-free rate of return. Are we on the same page? Are we on the same page so far? Any questions? Anyone lost? Now, if we expand this bracket, it means we can assume that there's a coefficient of minus 1j, right? So that we're able to expand this bracket. So which means as well, your alpha can be given as the return of the portfolio minus 1 multiplied by RF gives you minus RF. Minus 1 multiplied by RF gives you minus RF. Minus 1 multiplied by beta gives you minus beta. And this is multiplying your market return minus risk-free return. And that is the formula that they are also giving us in the textbook. So this is where that formula is coming from. So when they give you this formula in the textbook, where they say your alpha is equal to the return of the portfolio minus risk rate of return minus the beta in bracket market return minus risk rate of return. And this is commonly referred to as the alpha created by the portfolio. So when you talk about the alpha of the portfolio, you are saying you are trying to check to see what is the performance of the portfolio manager against what you were expecting to earn as a return. So you're comparing what is the actual performance of the portfolio manager, or how did the portfolio actually perform compared to what you were expecting it to generate as a return as well. That's basically what your alpha is in simple terms. So to understand this better, they give us example 1.3. Can you quickly read through example 1.3 and then we go through it together? So in this example, they say a portfolio manager is a portfolio with a beta of 0.8. The 1-year risk-free rate of interest is 5%, and the return on the market during the year is 7%. And the portfolio manager's return is 9%. The manager's alpha is equal to. So the return of the portfolio, which is your RP, is 9%. The risk-free rate of return is given to us as 5%. The beta is given to us as 0.8. The market return is given to us as 7%. And remember, the risk rate of return is 5%. So given this information, we should be able to calculate the alpha in this case. So to calculate the alpha, we are going to say the alpha in this case is going to be equal to, so your alpha is equal to the return of the portfolio, which is the return of the portfolio manager's return, or the return of the portfolio is equal to 9%. Now, on using the simplified version here, minus the risk rate of return, which is given as 5, minus the beta, they gave us as 0.8 in brackets. The market return was given as 7, minus the risk rate of return, which is equal to 5. So given this information, how much would you calculate and get as your alpha? So how much would you get as your alpha?
$2.4.
2.4.
So your alpha is going to be equal to 2.4%. So your alpha in this case is equal to 2.4%. All right. Are there any questions? Anyone lost before we proceed? Is anyone lost before we proceed?
Rhinos, how would you then interpret that 2.4%? Are you basically saying that the portfolio manager outperformed by that percentage?
Yes. So if your alpha is positive, so if your value for alpha is positive, it means the portfolio manager has managed to outperform. So if your alpha is positive, it means the portfolio manager has managed to outperform. So that's how you interpret these values for alpha. So if your alpha is positive there, it means your portfolio manager has managed to outperform. And if it's negative, it means your portfolio manager has failed to outperform the expectations. So if the value is negative there, it means that the portfolio manager has failed to outperform the expectations.
Yeah, Rhinos, my question is also similar to Thando. Earlier on, when you introduced the concept of alpha, you said it's an excess return, meaning something over and above. Now, when the value is negative, it's no longer excess. Do we still call it excess return?
It's basically a negative. It's negative. We just refer to it as negative. excess return. Because your alpha, sometimes your alpha is not always going to be a positive amount. That's what you need to make sure that you keep in mind, because your alpha. So the question is always, if the manager managed to generate excess return, or have they failed to generate excess return? That's typically how they would put it as well. Has the manager managed to generate positive excess returns, or has the manager failed to generate any excess returns as well? So that's typically how they would put it across. So the main thing,
I think that explains.
You need to indicate. So the main thing that is you need to be able to explain and indicate exactly. So have they managed to beat the expectations, or have they failed to beat the expectations? That's the main, the bottom line of the interpretation.
Now, lastly, in the example that we've just done, the risk-free rate was given as in 1 year. Can the question give us a multiple year risk-free rate?
No, because remember, this assessment that you're doing is over 1 financial year. So this calculation that you're doing is over, you're looking at the returns over 1 financial year. So which means that the risk rate of return is also going to be over 1 financial year as well.
Thank you.
All right. So going back to the text, they say on section 1.4, they also look at the arbitrage pricing theory. So they also look at the arbitrage pricing theory. And yet they say, remember, we looked at the capital asset pricing model as another way of determining the expected return. Another model that can be used in determining the expected return is the arbitrage pricing theory. Now, with the arbitrage pricing theory, just take note of the concept in theory, but not necessarily the calculations, because I've never seen the lecturer asking you to look at it in calculation format. So here they say, the arbitrage pricing theory can be viewed as an extension of the capital asset pricing model. In the capital asset pricing model, an asset's return depends on one factor. So with the capital asset pricing model, the asset's expected return is dependent on one factor, which is the beta. So there's one risk factor that we have to take into account when it comes to the capital asset pricing model. There's only one risk factor that you have to take into account, which is your beta. Now they go on to say, in arbitrage pricing theory, the return depends on several factors. And these factors might involve variables such as the gross national product, the domestic interest rate, and the inflation rate. By exploring ways in which investors can form portfolios that eliminate exposure to the factors, arbitrage pricing theory shows that the expected return from an investment is linearly dependent on the factors, which means it's linearly dependent, which means that the increase in the factors would also mean that the investor wants a higher expected return as well. On section 1.5, we also look at risk versus return for companies. And here they say, we now move on to consider the trade-offs between risk and return made by a company. How should a company decide whether the expected return on a new investment project is sufficient compensation for its risk? The argument just given suggests that non-systematic risks should not be considered when an accept or reject decision on a new project is taken. In practice, companies are concerned about non-systematic as well as systematic risk. So what does that mean? When you are assessing companies, it means that you need to take into account both non-systematic risk as well as systematic risk, which means when assessing companies, you need to take into account total risk. Because non-systematic risk plus systematic risk gives us what? Total risk, as we've seen in the demonstration of the breakdown of the total risk there. They go on to say, when expected bankruptcy costs are taken into account, projects that have a high total, which is systematic plus non-systematic risk, are liable to be rejected as unacceptable. This explains why, like companies to limit the overall amount of risk they take and reward companies that manage risk so that they meet earnings forecast as well. Now, to explain this further, they give us that example, which is business snapshot 1. I'm just going to go through it so that you take note of the basic understanding of that snapshot. And here they say, the heading is the hidden costs of bankruptcy, a hypothetical scenario. And here they say, several years ago, a company had a market capitalization of 2 billion and 500 million of debt. The CEO decided to acquire a company in a related industry for 1 billion in cash. So the cash was raised using a mixture of bank debt and bond issues. The price paid for the company was justified on the basis of potential synergies, but key threats to profitability of the company were overlooked. Many of the anticipated synergies were not realized. So furthermore, the company that was acquired was not profitable and proved to be a cash drain on the parent company. So after 3 years, the CEO resigned. The new CEO sold the acquisition for 100 million, which is 10% of the price paid, and announced that the company would focus on its original core business. However, by then, the company was highly leveraged. A temporary economic downturn made it impossible for the company to service its debt, and it declared bankruptcy. The offices of the company were soon filled with accountants and lawyers representing the interests of the various parties, being the bank and the different categories of bondholders, equity holders, and the company and the board of directors. These people directly or indirectly billed the company about $10 million per month in fees. The company lost sales that it would normally have made because nobody wants to do business with the company, with the bankrupt company. So intangible assets such as the relationship between built up over time, over many years with customers were lost. So key senior executives who had many years of valuable experience left. After 2 years and 3 reorganization attempts, an agreement was reached among the various parties, and a new company with a market capitalization of $700,000 was incorporated to continue the remaining profitable parts of the business. So the shares of the new company were entirely owned by the banks and the bondholders. So the shareholders got nothing. So this is another issue there where you look at what the bankruptcy effects as well, where the moment the company is declared bankrupt as well, it's usually downhill from there onwards as well. And these are this case study is basically demonstrating that. So please just take note of that for practical purposes. On section 1.5.2, they also look at financial institutions, and then they say one can argue about how important bankruptcy costs are for the decision making of a non-financial company, but there can be no question that it is crucially important for a financial institution such as a bank to keep its probability of bankruptcy very low. Large banks rely on wholesale deposits and instruments such as commercial paper for their funding. So which means in this case, confidence is key to their survival. Hence, they need to keep what? The bankruptcy, probability of bankruptcy very, very low. Then we also look at regulation, and here they say, even if in spite of the arguments we have just given, the managers of a bank wanted to take huge risks, they would not be allowed to do so. Unlike other companies, many financial institutions are heavily regulated. Governments throughout the world want a stable financial sector. So it is important that companies and private individuals have confidence in banks and insurance companies when they transact business. So the regulations are designed to ensure that the probability of a large bank or an insurance company experiencing severe financial difficulties is low. The bailouts of financial institutions in 2008 during the global financial crisis illustrate the reluctance of governments to let large financial institutions fail. So regulated financial institutions are forced to consider total risks, which is the systematic plus non-systematic risk as well. Then on section 1.6, we also look at risk management by financial institutions. And here they say there are two broad risk management strategies open to a financial institutions or any other organization. One approach is to identify risks one by one and to handle each one separately. This is sometimes referred to as decomposition. The other is to reduce risks by being well diversified. So this is sometimes referred to as risk aggregation. So both approaches are typically used by financial institutions. So please just take note of this as what? Potential short theory questions as well. Then they also look at credit ratings. And here they say, credit rating agencies provide information that is widely used by financial market participants for the management of credit risks. A credit rating is a measure of the credit quality of a debt instrument, such as bond. However, the rating of a corporate or sovereign bond is often assumed to be an attribute of the bond issuer rather than the bond itself. Thus, if the bond issued by a company have a rating of AAA, the company is often referred to as having a rating of AAA as well. And below, they give us the different ratings, which are also given by the three major rating agencies. You don't need to know them in detail. For practical purposes, you can go through them, but for exam purposes, you don't necessarily need to know how each one of them does the rating, although you just need to understand the ratings in general. So on this note, this is where we come to an end when it comes to chapter 1. Remember, for learning unit 1, we were asked to go through chapter 1 of the prescribed book. So which means we are now done with learning unit 1. So officially, we can now say we are now done with learning unit 1. So in the next class, we are going to look at learning unit 2. So in the next class, please take note that we're going to be looking at learning unit 2. Now, for learning unit 2, they expect us to cover chapters 2 to 4 of the prescribed book. So in the next class, we're going to be looking at chapter 2, which is part of what? Learning unit 2. Are there any questions? Any questions?
Yes, Rhino. So when assignment 1 opens, which is somewhere in April, we will not have covered all the areas that are stated as the scope for assignment 1. So in such a case, how are we going to manage that?
Assignments, I always assist you guys with assignments. So whatever question that you find are difficult, right? How we do assignment 1 is you share your questions with me, and then I'll also assist you with assignments as well. So it will depend on exactly how they structure assignment 1. So usually for assignment 1, how we look at assignment 1 is I'll prepare a template of question and answers looking at assignment 1. So which means what you need to do now is look at the question and see if it's relevant to the question that is being given to you as well. So which means I'll give you a template where there are possible questions, and all those possible questions also have answers as well. The only thing that you need now check is this possible question, the question that you have here, is it among those questions which are on the possible questions? And if it's not, then you also communicate with me, and I'll also update that question as well. But currently now, when it comes to assignment 1, we already have a database that we've accumulated over the previous, since 2020, we have a database that we've accumulated where there are possible questions and answers to those questions as well. So you usually use them to do that, because usually assignment 1 is online based. All right, are we on the same page?
Yeah, no, that's good. Take into account that, so it will be a quiz, and it will be timed with 2 attempts.
Yes.
Yeah.
Yeah.
So
I know.
I
We
think
have done
it's
this so many times. We have looked at these assignments since 2020. We know there's nothing, we're not expecting any surprises there. So we already have the database. We do have a database of possible question and answers. The only thing that you need to do now is to ensure that whatever question that they give you on the screen, is it part of the information in the database? Usually, if it's not, let me know so that I'm able to give you quickly the answer as well. Yeah, I see there's a raised hand.
Reno.
Yes.
Hi, Reno. Is the database available on the website?
No, I will share directly to the students. I will share the database of the possible question and answers for assignment 1. I will share them in due course. Yeah. Is there another question?
Yes, hi Reno. So I'm asking, like, for myself, I don't know if someone else is in the same situation as me. I haven't signed up for the trial thing because, like, it's obviously my first time in this class, but I've seen your videos in YouTube. So how do we sign up for the trial package?
Are you part of a group, or did you communicate with me directly?
There is a group that I'm in. I think it's for credit, but it's yours.
All right. Just communicate with me. I'll be able to assist you.
Okay, no problem. Thank you so much.
All right. All right. Is there another question? If you don't belong to your WhatsApp group now, depending on how you joined, there are different groups that have been set up. If you're not belonging to a particular WhatsApp group, please communicate with me so that we can assist you as well. All right. Is there another question? All right. If there are no questions, enjoy the.
I wanted to find out, when is the next class and will it still be free?
The next, because registration is ending end of March, we have decided to make the next class available for free. But make sure that you're amongst one of the groups, because we're going to be sharing the details depending on which group you're going to be belonging as well. So as long as you're on one of the groups, we'll be able to share that information. But I would encourage you to also create a user account on our website, because on that user account, you are able to access a soft copy of the textbook. You are also able to access the videos of previous class, of previous year's classes, so that you can use them to prepare for the coming classes as well. And whatever class that we did today, by end of day on Monday, that video would be shared so that you're able to access that video as well. Yes, I see there's another question.
Hi, Renos. It's not a question. I just sent you a direct message. Please check.
I'll address it just after class. I'm just waiting to conclude the class, then I'll communicate with you. All right, is there another question? All right, enjoy the rest of your weekend.